Hello, and welcome to the Scalawags podcast, episode 16, The Curse of Something We Don't Understand.
I'm leaving my monocle behind. The curse of something we don't understand. Man, I've been cursed a lot by stuff that I don't understand. I think I live in a state of permanent cursedom of not understanding things.
That's, yeah. Oh, wait, you need to see me. Hey. We
Hey!
should introduce ourselves,
There you
by the
are.
way.
Yes.
Yeah, no, this is the episode about the curse of the excluded middle. It was a post put out by Eric Meyer on ACM. But we'll start off. I am Josh Surrett. I work at TypeSafe. I do Scala buildy stuff. Next up.
I'm Seth Tissue, until recently of Northwestern University, now unemployed.
Oh, I was not aware of this change.
No, look, you never say unemployed. You say self-employed.
Yes,
Self-employed, man. Come on.
you're fielding exciting opportunities.
So did you just say, like, screw you guys, I'm taking that logo and I'm doing what I want? Or
I said that very, very slowly.
Nice. So I guess I'll get my intro out the way and we'll return to this. I'm Dick Wall, Escalate Software, Scala training, consulting, and actually lots of conversations about Scala this week too, so that's been nice. When I'm not programming Scala, I'm talking about Scala. That's always fun. Anyway, yes, Seth,
Yeah.
What's going on, man?
I'm not sure if that's proper for me to discuss in this medium.
Well, let me ask you something that's a more leading question, which is there anything people could send you if they're interested in maybe contacting Seth?
Is there anything people can send me?
Well, and is there
You want
are you
flowers?
soliciting opportunities?
Alcohol? What do you want people to send you?
Job offers?
I would definitely like some of whatever you're having, as far as the wine and whatever else.
Yeah, I am pretty junked up tonight. I've got the Zyrtec going and the wine.
Cheers, guys.
I live in a good place right now. It's not a particularly clear place that lends itself to clear thinking, but it's a good place.
Yeah, so Seth Tissue is available as a self-employed man right now. If you're interested in hiring a great Scala developer, everyone send him your company's resume. Please.
And if not that, send him Aquavit and Lutefisk. Because everybody needs more of those.
Yes, if anyone wants to hire a smelly, unemployed bum, I'm available.
So you just named like half of every engineer out there. There's a smelly unemployed bum in all of us. Anyway.
Excellent.
Yeah.
So we are here to discuss this paper by Eric Meyer, which has it attracted some attention? Is it like a lightning rod for a controversy, or are we here to make it?
I only heard about it because Josh sent it to me.
It came out April 26th, so it's not that old. I mean, that was what, Saturday, and it's on ACM. I thought it was an interesting paper from Eric Meyer. For those of you who don't know Eric Meyer, he co-taught the reactive course with Martin Odersky and Roland Kuhn. He did as far as I understand it, he was the guy responsible for reactive extensions and making it happen, and then also contributed heavily to RX Java, if I recall correctly. But I'm hazy on the details of all.
No,
of
I
that.
think you're right. Yep, I think that's all correct information. I'm going to add a personal observation about him. I think Eric is one of the nicest guys I've met. I love him to bits, but I cannot get past the fact that he reminds me totally of Goldmember off of Austin Powers every time he does a talk. It's like this massive thing, and I'm sitting there, and I'm like, Goldmember is telling me about functional programming. It's awesome. So I love Eric. He's a great guy.
And you pay extra for that, I assume.
Yeah. Oh, it's great. I mean, I'm sitting there. I'm fully entertained. All of my senses are engaged. It's excellent.
So I learned today that in addition to Eric's responsibility for Link and C# and other things, that he was quote on the core team for Hacked, the PHP dialect.
I didn't know what that was. I had to go and look it up.
He was on the core team for that?
This is a direct quote from an official Facebook page. Now, I do have to wonder if that is actually accurate in the sense that I mean, normally core team, I would imagine that he was actually like pounding the keyboard, and I kind of wonder if it wasn't more of a consulting thing, but who knows?
I do know that the little bit I know of Hack, or the development of it, like those guys are super sharp and like, used a lot of interesting stuff in there. So that's kind of cool. But let's get into the paper. In fact, I think to get into the paper, the first thing we should do is answer one of our live questions. So
I haven't got the live question thing up. Hang on, let me bring it up here.
Thank you, Daniel Sobral, for posing the obvious question. What is the curse of the excluded middle? The excluded middle, I looked it up on Wikipedia, and I defined it, and then at the end of it, it was like, this is not to be confused with X, and then it was what I just said. It's like, with the excluded middle, something is not allowed to be neither true nor false. It has to be one or the other, except that's actually wrong, apparently. But anyway,
yeah,
it's
more that if it's either this thing holds true or the exact opposite holds true, which is different than true and false subtly.
So it seems to be a reference to a possible strawman concept of something called mostly functional programming. I'm not sure if this is a term that other people actually use, but the basic thesis of the paper is that there's no such thing as mostly functional programming. You need to be doing pure functional programming, or you need to get out.
Yeah, basically.
And I was surprised actually, because in functional programming community just lately, I feel like Eric has attracted more attention as a kind of heretic, or as someone who's out there, working on a PHP dialect rather than adding towers to adding new spires to the ivory tower. So, but this is a paper where he takes a pretty hard line about the necessity of doing pure functional programming, and saying that we all need to learn about monads and so forth.
Yeah, I think this is actually a change in his viewpoint, because up until this point, he was of the opinion that you use monads where they're useful, and you use mutability where it's useful.
Yeah, it does seem like a change in the message that he's been giving out for some time. I mean, if you take that to its conclusion, you're probably thinking that Scala might not be the right fit, because Scala gives pretty even kudos to both of these approaches.
Yeah. Well, to finish the answer to the excluded middle,
okay,
I think the core idea of the excluded middle is that you can't live in the middle. You have to live on this extreme or that extreme, because there is no such thing as a middle ground. That, I think, is the crux of his debate. So I'm going to close the curse of the excluded middle and move on to our next thing. The next question fits into what you just said, Dick, which was, this is from Franklin Chen. He's a Pittsburgh guy. Rock on. I couldn't tell.
Have you guys got a Pittsburgh sign that we can do?
I don't know, man.
Like
we can make one up. Yeah,
probably the other way around for you.
It's got to be cooler, man. P. I don't know.
Oh, yeah, okay.
I don't know. But yeah. Okay, anyway. The question. I couldn't tell whether this was trolling, because isn't he a Scala fan these days? And yes, like Eric and TypeSafe, like we interact with him frequently.
This is one of the things that's a little hard to figure out about the article is exactly who he's criticizing. Like, who are these people who are selling this silver bullet of mostly functional programming? It wasn't obvious to me.
I am with you. I actually looked through the article in my holistic hippie way to sort of say, who's he trying to talk to? Who's he aiming this at? And actually, I sympathized with some of it because some of this stuff I've been thinking about in the context of Java 8 recently, Java 8 coming out. And one of the things in particular that I think does lend itself to a certain amount of danger is, suddenly lambdas are available in Java 8, and you've got these functional approaches to things, but all of the core collections are still pretty mutable inside of Java. And I think that is going to lead to a lot of confusion and, weird, unfunctional or dysfunctional code that people can't reason about well. And I can sort of see that. Sorry, Josh, go on.
If you look at his examples, you're right. All of his examples are based on C# and LINQ. And really hammer, like C#, I would say, is more advanced than Java into the functional world. They have basically C# lambdas and LINQ are a lot nicer than Java 8. And I'm gonna say that. I'm sorry if I tick people off. It's okay. It's nicer. We can admit to it. The thing is that his points really do kind of apply there with some of these corner cases that confuse people. And we had the same experience with the Scala collections. Have you tried to use mutable Scala collections intensely within Scala? Or do you use them as immutable collections, right? Like, as soon as you start getting into the details there, things get a little confusing.
Yeah, I mean, so, to sort of talk about my experiences a little, I've had very, very good success with just using immutable collections like vector, and actually, in some cases, just the parallel vector and the whole parallel implementation of work stealing and throwing that at a great big Monte Carlo engine worked beautifully. I didn't have to do anything else. Just use the immutable collection, spawn off, a couple of thousand of these things, send them out, and let the workers take care of the problem, and it worked great. Now it's not a universal solution. None of these things ever are. But in that situation, it worked wonderfully, and all I had to do was basically stick this thing in a vector, randomize a few things, change the vectors just a little bit in places, and then do a par and a map on it, and Bob's your uncle, as they say. It was great.
Yeah, so what's interesting about that, because my example is I just recently added parallelization to Ivy downloads. Just on a whim, was experimenting with it, right? And the way that you go about that, because Ivy is super, 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 super mutable in its core, is you take the algorithm, you take a piece of it, right, that you want to parallelize, and you figure out what are my inputs, what are my outputs, and I construct immutable objects. Then I farm this thing out in the parallel world, do my pure function, where I guarantee, like, if there are side effects, I actually don't. They're not the kind that I care about normally. Like, they're like JVM failures, whatever.
Yeah.
But I try to capture everything in this pure function, farm that sucker out in parallel, and then when I come back, I do all the mutation that Ivy expects. And it works, and it is parallel, and it does improve the download speed. Does not improve resolution speed for other reasons, but that's generally my approach to functional programming, right? There are I need to, and this again, people make fun of pure FP, but you invent this made-up universe where everything abides by the law. And then you take your system and you map it into this universe, and there are all sorts of things you don't have to worry about, and all sorts of benefits you get because everything pays attention to the rules. Everything will fit your mental model. It's like taking something from the real world and putting it in the Platonic ideal, and then coming back to the real world when you're done with the thing that you just transformed. And it's not perfect, but man, that for really complex bits of code, that's like makes it so much easier to read
Yeah.
about.
And
Yeah.
and I'd say that's a good balanced approach. Is you said it there, really complex bits of code. I don't and in fact, one of the things that I kind of wanted to get into here is my first glancing experience with functional programming was back in university when I used a language called Miranda, which is a forerunner to Haskell. And the whole monads thing hadn't really come about as an idea or a concept that could be used in there. So Miranda was very strict, very functional, and actually was really interesting, but kind of useless. You couldn't do a lot with it because you couldn't get any sensible I/O with it or anything like that. You kind of wrote your program and had everything defined, and then it would run and it would give you the results at the end of it. And you're like, yeah, but what if I want to type in something or have it react to something the user's doing? It was actually really difficult to do. And Monads has definitely given an approach for doing that, but ultimately Monads are a way of segregating your state transitions and your side effects. They don't get rid of them altogether. If you have a program that has no side effects whatsoever, it doesn't do anything. Anything useful that it's going to do is some kind of side effect.
Yeah, the devil's advocate to that is that effects and side effects are kind of different, right?
Okay, yeah, that's true.
Right,
Yeah.
I think that's the terminology that Eric uses in the paper, and that I think is good terminology is to say that these things like doing I/O are effects, and if they're in the type signature, we call them simply effects, and if they're not in the type signature, if
I
they're
see.
happening, then we call it a side effect.
Yeah. Now, can you capture something like, and I kind of figure, looking at his paper, I think that's what he was trying to say. I'm not sure I actually got the answer to it, but something like, allocating memory. Can you represent that in a type system? If you're creating a new instance of something.
The answer, can you represent stuff in a type system? Usually the answer is yes, you can represent something in a type system. Is it practical to do so? Is a question, right? Is it practical to represent memory allocation in the type system as a thing that could fail?
Yeah.
Haskell, I think, is actually a pretty practical. I will misuse the term pragmatic language when it comes to how it defines pure. Okay, it allows exceptions. It allows runtime exceptions. And those kind of escape this notion of purity in Haskell. They happen, but generally, there is a question right now. Sorry, that Dick is answering.
I responded to the question, "Where are the pirates?" by becoming more piratey.
Yeah.
Yar.
I'm gonna respond with a live hack.
Actually, and while we're off, I didn't want to derail you while we were on the topic. Your microphone is a little quiet, Josh. Can you turn it up a bit?
Oh.
What I can do is talk right into it.
Yeah, I think when you do that, it turns it down even more. So now
how's this?
That's actually good.
This thing I've got to pirate gear for you guys.
You guys are pretty seriously piratey.
That's legitimate, man. Where's your motorcycle?
I think we have responded resoundingly to Daniel's question here, Daniel Sobral.
Okay.
I think we have. Yeah, we're represented the pirates right now. Anyway, to get back to the thread, I think Josh, you were on the thread, so pick up the thread again, man.
Yeah. So the thread was like purity and stuff. When it comes down to it, like the computer is a physical thing. There's actual memory. There's a possibility of failure. Things can go corrupted, like USB drives stop working, that sort of thing. There's all sorts of weird things that happen. Okay, but it's still useful to create an abstraction where you make assumptions on like here are the things that I'm going to deal with in my program, and here are the things that are outside of my concern, so that you can actually write the program and get it done, right? I mean, It's like in physics. The calculation you do is a model of the real world. If you
Yeah.
actually tried to calculate it perfectly, there's so many weird things here and there you'd have to throw in that it just is impractical. So use this approximation of the real world.
I've got a perfect example of this that I can pull out. I'm sure you guys have heard the etymology behind the term bug in the software, right? You guys know the story?
No. Oh.
The vacuum
bugs.
tubes.
Well, it was actually core memory. It was back in the days of magnetic core memory, and the computer scientists were working on this machine, and a moth flew into the core memory and stopped the program working. And so literally a bug stopped the program working. Now, if you take it to that extreme, you actually have to come up with a type to model the moth flying into the core memory as one of the things that could happen. So I think possibly you can take this too far, yes.
But
I think I've heard people say that they've like with respect to exceptions, that it matters if you're talking about catching exceptions or merely throwing them, right? Because if you're just throwing an exception, then it's like you've exited the system.
Yeah.
But if you actually catch it, then that's no longer the case.
Exceptions definitely are a pain in the butt when you're doing, and I can side 100% with Eric on that. When you introduce when you throw exceptions, you're actually interrupting the normal flow of execution, and it makes it really hard to reason about, and also to catch those exceptions. You don't know. One of his examples is very good. The exception doesn't get thrown where you think it does anymore. It looks like you're handling it in the right place, but because of the nature of that function being mapped, it actually doesn't happen till later, and then there's no handler when it actually executes and the exception is thrown.
I thought all of his examples were really good examples and reminded me of things that I'd actually seen of, like basically what happens when you to people who haven't used this stuff before. And so you just like, here's the imperative tools you already know. Here's some functional stuff. Here's lazy data structures. Go for it. And then people will definitely at first produce this kind of dog's breakfast of mixed idioms where things can go wrong in crazy ways. And like, those of us who, after we've been doing this longer, we look at that code and we're just like, oh no, like yeah. You have to do it more like Josh described, where you sort of carve out parts of your program that are pure, and put yourself in that mindset in those parts of the program. Like even if you're not going all the way and writing a complete application that's where every function is pure, the whole thing is functional. You need these new techniques, these functional techniques that maybe you've just learned if you're a beginner. They really shine when they're combined with each other and not just thrown in with the old stuff.
Yeah.
So if there's a pause in the conversation, I find the concept of what you're saying is, okay, what can we model in the type system? What effects can we model in the type system? One of the ones that, and I'm not even sure this is a fully coherent thought at this point, again, Zyrtec, alcohol, but one of the things that I've just been dealing with is I've been working using Scala Z streams, which is a very functional library. Very functional indeed. And one of the problems that we've had, and actually, I want to get into this as a topic sometime as well, because I think there's some mileage here. Biname functions, a good thing or a dangerous thing, or both? Because one of the problems with binames is you can very easily invoke them not meaning to. That's the problem with binames. You can refer to them, or the compiler won't catch suddenly eagerly evaluating a biname when you don't don't mean to. And that's actually exactly what's happened in the current implementation of Scala Z streams. And the manifestation of that in what we saw was we're working with these streams, we're doing everything correctly, we're getting exactly the right answer, but the results are taking a ton of time to come in, like a really long time to come in, hundreds of times longer than the imperative code that it was replacing. In some cases, thousands of times longer. And it turns out that these biname functions were actually getting invoked every time there was a wait state when it's not supposed to be doing any work. It's supposed to be waiting for the next, it's an iteratee. It's waiting for the next delivery to accumulate it. But it was firing the biname functions and then throwing away the results every time. And there was nothing that the compiler could do to catch that situation and tell you that it was going on. We actually had to observe it, and we had to observe it using side effects to find out what was actually going on in there. And that's an irony right there. I'd love to get into that as a conversation starter sometime. But actually doing a print line showed the problem. It showed that this thing was being called like 30,000 more times than it should have been.
Is it Heisenberg's uncertainty principle, right?
You need to observe what's going on inside the box. Yeah, it's the Schrodinger's cat. You got to look at it. So eventually, you got to look at it.
Yeah. So that actually, from my experience, that was a common bug in Scala Z. Bug, if you will, just like optimization, missing optimization. Everything was correct, but you might evaluate a function more than absolutely necessary.
Yeah, I don't think this is
for that reason.
I don't think this was optimization. I think this was literally just a missed thing. It's it was eagerly doing something, and it's because of binames that, like I said, it's all too easy. When you have a zero parameter function, an empty param function, you don't invoke it accidentally. You actually have to invoke it with empty parens. Otherwise, it just remains a function that you pass around. But the problem with a biname is invisibly the compiler will take this biname function, and if it needs the result of it, it will just go ahead and execute it right there. If it needs the type of the result rather than another function, another biname function, it will go ahead and do it there. You don't get any compiler indication that that's happening.
That's actually, Scala by default is eager, and that's lazy. So there we have a question, another question from Franklin Chen on this. Meyer,
I missed it.
It says Meyer praises laziness, but many think laziness is a hidden effect, possibly like the ML community. For example, Idris has typed laziness, where it's part of the type system, whether or not it's lazy. And that's actually, in my opinion, legitimate. Like I think you're right that by name parameters, it'd be handy if there was some way of catching when they evaluate.
At least a warning that you could turn on that it's so difficult. I mean, in this particular instance, the problem was a case class that needed those types, and the creator of that case class had the biname that resulted in that type. And the compiler said, oh, that's no problem, I can just, it's a biname, I'll just give you that type. You really want a warning to be turned on when you do that, but if you just refer to it, at some point you actually want to refer to the thing by name and have it execute it. So you have to have a smart enough compiler to say, I think in this situation you really wanted to pass this thing along as a function, but in this situation you do actually want to invoke it, or something like that. I don't know.
I think
it's a tough one.
There's a missing feature in Scala here, which is the ability to declare a parameter as lazy, right? Your two choices are the parameter can be strict and you just get the value, or you declare the parameter by name and then it's evaluated again every time you mention it. You ought to be able to just say, this takes a lazy parameter. It's evaluated at most once. That option isn't available.
Yeah, there's a little bit of overhead to make something an at most once variable. Like if you look at lazy vals in general, there's even some angst there. So a lazy value right now is a lazy value at most computed once. And, well, okay, that's actually not true either. It could be computed more than once if it throws an exception the first time and you try to reinitialize it again after the exception thrown.
Yeah.
So it could evaluate more than once, but theoretically, it's evaluate once.
It will complete at most once.
It will complete at most once, yes. In that it will actually return. The thing about lazy val is it's tied to concurrency. So every time you use lazy val, you actually have this bit set to like flag whether or not the thing has been computed, and then you have a synchronize block to synchronize on the value and set it to prevent anyone else from doing the same thing. And that's because you're living in concurrency. But lazy vals tend to get used to defer initialization when there is no concurrency in place for something that just is going to run in a single thread. And when that's the case, you're paying a hefty penalty for all this concurrency stuff when you don't need it. So
yeah, I think my own single most common use of lazy is just to break initialization order problem.
Yeah, that's number one. Yeah, definitely. And occasionally I do use it as an optimization when I know something's going to be like a really heavy computation and might not be used. Those are really the two things I use it for.
Yeah. Well, so the practical thing with initialization order is that construction actually needs to be split in twain. In twain. Is that a good word? So
I think you mean cleaved. Cleaving is cleave is actually a really interesting word because it means both to put two items together and to split them apart. It is its own opposite, its own complement. Anyway, that was totally Zyrtec and White speaking. Right?
So we need to cleave it. But no, there's like when you have a value in a class that depends on some abstract thing, you need that abstract thing initialized first. So you actually want to you really want to shuffle around initialization order if you allow that crap to happen.
Yeah, and actually that the problem there with lazy is the domino effect. Lazy's fine as long as everything is lazy. The moment you have the first non-lazy, it knocks all the dominoes over right then, and you could still get the initialization problem. So you can do it all right, and somebody comes along just a little later in a trait and forgets to make that thing lazy, and suddenly you got the problem back again.
So related to this, Franklin actually made another thing where he created a...
Is this your Pittsburgh homie again?
This is the Pittsburgh homie. He's talking about lazy.
He's pretty prolific.
So he had I think he's one of the 3 people watching. So he made a it's called Scala Fair Stream. There's a link in the currently answering right now. We'll put it in the show notes then. So it's notes about writing code and laziness with Scala and making sure that things stay lazy. So one of his frustrations was not being able to use an extended pattern match syntax with laziness support. So yeah, there's an interesting problem in Scala in that we are an eager language and we try to support laziness, right? We try to support laziness as best as we can, and there's things that expose it. But it's one of these things. Laziness might also be an excluded middle thing. Like you said, it's viral. Once you go lazy, like that whole area of code kind of needs to stay lazy. And same with eager. Once you go eager, it's hard to blend between the two.
Yeah.
So you tend to have areas of code that are eager and areas of code that are lazy. Eager code, I feel it's easier to understand how to write performant eager code because that's what you're trained to do in school. You're trained in how the machine works. You're trained to do it that way. Whereas like lazy code is this new crazy thing that people don't necessarily know how to optimize, and I feel like we're still learning in that area. So there was a proposal for the actual lazy syntax keyword to have optional strategies for how that gets encoded. So you can decide on the exact mechanism that it is lazy. Is it thread safe lazy? Is it just on a single thread lazy? Is it construction lazy? Since a lot of people use lazy val for construction. But that doesn't actually solve Franklin's problem of being able to get it into pattern matching with backtracking, so that if you pattern match through and lazily compute things and it isn't correct, you have to like backtrack to the thing again. Yeah, good times, man. That's actually a pretty cool library. So we'll put it in the show notes.
Cool. Yeah, I've been sort of letting my mind wander during your last statements there about just going back. No, just hear me out. Just going back to the idea of bynames, and it makes me wonder. Of course, I'm not a language designer, nor do I have any claim on the intricacies of what this would mean. But it's almost like with byname, you actually want something. You don't want it to evaluate by name. You actually want to say, okay, I'm actually ready to fire this thing now. And if you don't put that on there when you want to use it, like, I don't know, an exclamation point after it or something like that, do it now. Without that, it remains a function and it remains a compile error if you use it in a way where you want the resulting type.
I actually think that would be legitimate, and you could just you instead of by name, because by name turn into function zeros anyway. You can have something that lifts an expression into a by name. Like if you use by name, it lifts it into a function zero, but you treat it in all other ways as a function zero. Or there's some type that you would explicitly specify that has an apply method that you could lift into. That would work.
Because the reason as far as I can tell, the reason bynames really exist is to make Scala look pretty when you've got function zeros, and you don't have to put the open close parens and the rocket in front of them. You can just put curly braces in your code, stick something in there. Yeah.
The rocket? It's the double arrow, man.
It's the rocket operator.
That sounds so 90s, man. That's
I want to be sure I understand what you're suggesting. So you're saying that if a parameter was called by name, then at the call site, you
actually have to do something to say.
It would work as it does already in the language, but then in the body of the function that takes the call by name parameter, you would just see the type as a function zero.
Yeah, or something that's equivalent to a function zero. Maybe some type of function zero.
I wonder if that was considered, because I've certainly run into the situation where it's like I want to hang on to it. I want to pass it to something, but I have to wrap it in a function zero myself in order to do that.
Yeah, you can do it if you're very careful. You can pass it along.
Right.
But that's the thing. It's far too easy to get it wrong. And then when you do get it wrong, the compiler doesn't tell you. It's like, oh yeah, you can do that. Yeah, no problem.
Yeah.
I'll fix that right up for you and run it right now. And you're like, no, I didn't want to do that. Yeah. Stop helping me.
So was there anything in this paper that we really objected to, any of us?
No, I think I don't agree with everything in there, but it's hard for me to point a finger and say this is definitely wrong. What I would say is that my experience has been I've found a mix of the two, as long as you're careful with it, works pretty nicely. A mix of the two styles. I mean, my approach is code that can be functional, definitely make it so. It makes it easier to all the reasons that he says. It makes it easier to reason about, easier to test, all of that stuff, and you can unit test the hell out of it. When you get to the code that actually, is the kind of behavioral code, the stuff that's really hitting databases and all that sort of thing, life does suck more. But this is what functional testing was, or acceptance tests were written for. The higher level, bigger non-unit tests. That's what we do those things for. It does suck, but it's, kind of the way things are. And I do think that going to the extreme of trying to keep everything 100% purely functional, 95% of the time that's great, and then 5% it hurts you more than it helps. That's my take.
Yeah.
I'm sure. Sorry, go on.
Well, so I think I agree with this paper, but only if I read it in a certain way, which I'm not entirely sure is the way he intended. So here's how I read it that makes it match thoughts I already had, which is So, like, I mean, when I talk about functional programming, I've never done a greenfield functional application where I'm just writing functional code from scratch. Like, my experience has always been I've got this big, massive Java code. It's all imperative. I've got to convert it to Scala, try to make it more functional. So when I'm doing that, I definitely feel that I've learned from experience that it's more important to find parts that are key and make them 100% functional than to have like a massive code which is sort of mostly functional most places, but it doesn't actually have, like, if you have no pure functions in your code, then you failed. Like, the first thing to do is to try and find one function that you can make pure, and then
Test it.
and
Like
test it,
plus.
right? And then you try and make more of those pure functions. You try and collect those pure functions
Yeah.
together into purely functional modules. But it's not good enough that a function is 90% pure. 90%.
Not a function, but I think overall your program.
Right. So, but if overall if elsewhere in your program you have other stuff that you weren't able to get to functional nirvana on, it's fine. When you do your triage of like where is it important for it to be functional, you've got to find places where you can go 100% in order to get the real value,
Yeah.
even
Now,
if it's not the full app.
The question I would then throw in there is, based on what Eric said, does 100% pure functional mean no new instances of anything? Because that's really tough when you start getting into that of, well, I'm not going to create a new instance of a case class or something like that to return to use or whatever. Then you really start to hamstring yourself. It's not that it can't be done, but it does make life significantly harder.
Yeah.
Well, that's what we had to do for highly performant, like, weird C++ code back in the day.
Agreed, and embedded code works that way as well. And it's really hard to write big programs in an embedded approach.
So I kind of want to read the conclusion here, because maybe that'll clarify a little bit, but the conclusion in the paper is the idea of mostly functional programming is unfeasible. It is impossible to make imperative programming languages safer by only partially removing implicit side effects. Leaving one kind of side effect is often enough to simulate the very effect you just tried to remove. On the other hand, allowing effects to be forgotten in a pure language also causes mayhem in its own way. Unfortunately, there is no golden middle, and we are faced with the classic dichotomy, the curse of the excluded middle, which presents the choice of either trying to tame effects using purity annotations, yet fully embracing the fact that your code is fundamentally effectful, or fully embracing purity by making all effects explicit in the type system and being pragmatic by introducing non-functions like unsafe perform IO. The examples here are meant to convince language designers and developers to jump through the mirror and start looking more seriously at the fundamentalist functional programming. So I think what he's trying to say is basically, look at both sides. Look at both sides. And apparently people can't hear me. So
yeah, you were getting a bit quiet again. Well, I could hear you all right, but you were definitely getting quiet. And people deserve to hear your valuable, your insightful views on this stuff, Josh.
Yeah,
you're
okay.
denying them. You're denying them
I'm
the
denying them the insights.
But you shouldn't be complimenting his views. You should be complimenting his eloquent reading.
Oh, and his wonderful masculine baritone voice as well.
Ooh,
all of these things.
Compliment. Baritone is a compliment. Yeah.
It is. No,
yeah.
It's a good. You got a good set of pipes on you, man.
Nice.
So one thing in the paper that I can't say I disagreed with, but I thought that was intriguing, and I wondered if it's true, is he kind of comes out swinging at the end, saying that other approaches to controlling effects or representing effects in the type system, other than using monads, are, no good. They're too esoteric. You need a PhD in computer science to understand them. Like he kind of the things that the people who find a lot of people think monads are esoteric and take a PhD to understand. He uses similar wording about things like linear typing. He seems to think that stuff isn't going to pan out, and I would love to hear maybe afterwards from anyone who's listening who disagrees with that claim in the paper and thinks that that we'll find better abstractions than just using monads for everything. Which is, I'm caricaturing a little bit, but I'm not. It's not much of a caricature. I mean, that's pretty close to what he actually says.
So I think if you look at actually even the Haskell community, right? I mean, there was a time where everything was a monad. And then we ended up with monad transformers and monad stacks and all the fun monad zippers. That was my favorite. I mean, all sorts of fun that goes with that. But they've started exploring a new space where they try to force everything to be applicative.
Yeah. And it seems to me that the Haskell people are always complaining about their monad transformer stacks. It's like it seems to be a popular thing to moan about. Like they're not happy with it.
Yeah, I think we can do better than the IO monad in terms of tracking effects in a type system. I don't know if linear typing is going to pan out, but honestly, I don't care if it pans out or not. I'm just happy someone's researching it.
Yeah, exactly. It doesn't have to work. It just has to turn up. It has to turn up useful information that we can apply to other things.
That's what research is all about.
Exactly.
You should be willing to fail. If you're
Absolutely.
not willing to fail, we can't learn.
Yeah, no, I couldn't agree more.
Yeah, and I think actually I'm going to put words in his mouth, but I think Martin might be waiting for something like that. I mean, they've put some EPFL research into an effect system for Scala, and if you notice, there's no effect system in Scala right now.
Yeah.
And I think that's because they're still waiting for something that they feel is practical in Scala, and it could be that nothing exists. But I don't feel like we've actually explored that space enough. And I also think that when it comes down to it, something that is practical for someone to use and understand doesn't have to be practical to actually understand the concept behind implementing it. And that
right.
Like I use electricity all the time, but I don't necessarily understand everything about flux that goes into the transformer that's sitting outside, right? So,
is your flux capacitor fluxing? That's the question.
Yeah, I would love to know what, for example, what Eric Meyer thinks about Edwin Brady's recent paper on representing effects in the Idris type system using dependent types. That doesn't seem to be on his list of alternate approaches.
Maybe he didn't see it. It says "love it, hate us, let us know," and there's a bunch of comments. And I think
actually one of the comments
there might be more comments.
Yeah, one of the comments I found particularly insightful, it certainly rang true for me, is one of the first assertions he makes is that, almost functional is like saying almost secure. And somebody pointed out that really, if you dig into it, that's all we have. Perfect security does not exist in any computer system that I've ever seen. If it did, you couldn't get into it to use it. I mean, it would be so tightly bound up. So the best we have is, two factors pretty effective. But is it perfect security? No. People get their accounts hacked all the time still. There is a compromise there, and I think that is telling that the kind of the first analogy he makes breaks down when you actually examine it. I think we need to dig deeper into that. I love you, Eric.
If the paper is a call to look more at the people who are claiming to be pure functional programmers and go closer that direction, I can actually, from my experience coming from Java into Scala, that's the direction I needed to move. Because to take advantage of massive parallelism on my 12-core machine, the techniques I was using before just don't work. But if I make this imaginary land where everything's pure, I can actually put a computation on a 12-core machine and have it scale. But, I've limited the universe to this little piece. And it's not everything I could do before. And I do that specifically so this piece is easy to write because it's the most important piece of the program. So I make that piece easy to think about, reason about, and fragment. And I've purposely limited myself. I've gone to the platonic ideal and invented a universe.
And if the thing that grabs the data out of a database so it can be processed before that runs and then sticks it back in the database afterwards, if that's not purely functional, big deal. The bit that's running 12 hours to actually do the computation, that's what needs to be parallelized. So yeah, it's a good discussion point. I appreciate that Eric has brought it up.
Even Haskell has a VM, right? That's where the impurity lies for a lot of the Haskell code that runs is the implementation of the VM. But you have well-defined semantics of the thing you're running, so you can really fine-tune that sucker and do some cool stuff. You know. Let's answer. So there's one question that's been open for a while. Let's answer two of the questions if that's okay. This is from Thomas Lazaro. Or Thomas, I don't know. I can't pronounce it. I'm going to be terrible. And it says, aren't there some upcoming JVM features that would enable native lazy mode? I have no idea. I should know that. Does anybody know that?
I also have no idea.
Sorry about that.
I tried to Google it real quick, but I couldn't find anything.
We should stick that in the show notes and see if anyone knows the answer.
It sounds like the kind of thing John Rose would be looking into. If I was a betting man, my money would be on John Rose doing it. So maybe somebody knows.
So
but
either we take Dick's money or we talk to John Rose about it. One of the two. I vote for taking Dick's money.
Okay, sure.
Yeah.
I got at least a couple of dollars left after dinner, so those are up for grabs.
Whoever wants $1 can have it. Okay. All right. The next question is this is from Franklin again. Meyer is referring to stuff like extensible effects as an alternative to monad transformers. So Haskell has an extensible effects things. These mechanisms seem pretty esoteric right now.
So that URL is Oleg's site.
Yeah, extensible effects and alternative to monad transformers. That's more of a statement than a question, and I would need to read into this.
I think Franklin was lining you up for your esoteric ecosystem enumerated section tonight. He's lined it up beautifully for you there.
Yeah. Hey, are we done actually?
It's a Haskell library. What?
Are we done actually? We swore that we weren't going to talk all night tonight.
Yeah, we should maybe reel it in at this point.
I think. So we finished all the questions. That was more of a statement, and we'll include that in the show notes. The extensible alternative to monad transformers. I agree with you, Franklin, that does look a little esoteric. It actually, the syntax looks kind of similar to the stuff that I saw out of the effect tracking in Scala. So yes, I would agree that it's not necessarily something people would dig into. I think we actually did cap the show off about 10 minutes ago, and then I decided to try to answer the last two questions. So anyone want to restate what the cap was? Our consensus?
No, my conclusion was that I don't really have a conclusion yet, but it's a very interesting topic.
So I'll throw this out there. The excluded middle. I think that in the same way that once you start with lazy programming, to maintain laziness, everything around that needs to stay lazy. And it kind of is viral. I would say that functional programming is like that as well. Once you start trying to do functional programming, you need to start pushing out more and more effects. And it's a viral thing that starts to take over an area of code. But it's also really handy to do so in real life, to limit the scope of a piece of code. I think we kind of all agree about that.
Yeah. Actually, Franklin has... I was going to say, Franklin's asked a really good question. Okay. I know we're supposed to be bringing it in, but I want to answer this one. I want to talk about this one.
All right, I'm gonna click on it. I clicked on it. We can answer it.
Okay, so going back to the security, it's like having partial security or mostly secure systems. He says security people have been doing a lot more work in social engineering and side channel attacks. I know that's actually a hobby of mine, and I read up on it a lot. Are you suggesting that in talking about programming languages, we should be focusing more on the big picture rather than on perfecting a particular model? Yes, I would say unreservedly yes. I can't. I actually, one of the things that I think I may do in one of the talks that I've got coming up is just list off the top of my head the top 20 things that have been a silver bullet in my career. That people have been like, oh, you got to do this. Everything's going to work this way. When has that ever been the case? There are no silver bullets. That's the first thing you learn. And all of these things have a place. They're all extremely useful. Getting a grasp on the holistic, on the holistic picture is far more important than we must do it like this now. And in fact, I had a conversation not so long ago, not mentioning any names, but had this conversation where somebody was trying to put together this little library to make it easier to write, to write graphics, do some graphic stuff. And they wanted to make a purely functional, all monadic, all composable library. And I'm like, I think you could probably get the result that you want with some decent, nice, immutable builders, and you'd make everybody's life easier. They'd have a discoverable API that they could use, and all of this sort of thing. And the response was, but then it wouldn't be composable. And that was the argument. And I'm like, does it need to be for this library? Think about what you're writing. Does it need to be composable? That's not a reason to do it that way. That's a reason you're giving because you want to write it like this. That is not actually a requirement of this thing. It has to be discoverable. It has to be easy to use. It has to be obvious and simple for the people who are using it. It does not have to be completely composable. So, yeah, I would say on that one, Franklin lobbed me a softball because I feel that very strongly that way. That any of these, you got to do it 100% like this. They're all doomed to failure in some way.
I'm gonna take a holistic approach as well. I'm happy that somebody tries to perfect a particular model.
That is very true too.
I think that by taking a model to an extreme, you learn the boundaries, and I'm happy for somebody else to do that, and then learn from what they've learned. And be able to holistically do things,
right?
Across different paradigms, across different languages. When it comes down to it, I have to get paid to do what I do, and I also want to enjoy it. So I like to learn a lot about everything that's going on to try to avoid failing. But I still need to be willing to fail as I learn an area that nobody has done before. Usually if I'm getting paid, it's to do something nobody has actually done this particular task before.
Yeah.
Or I'm probably not getting paid very well, and my job is probably at risk. One of those two. Anyway.
So just...
Yeah.
Yeah, and I'll keep it short. I'm sorry, Seth. I'm very, very sorry I keep talking. You guys have heard the term pushing the envelope, right?
Yeah.
Yeah, do you know what that's from? Do you know where that comes from, the term pushing the envelope?
No, never thought about it.
Okay, now it's an aviation term. Okay, when you're flying a plane, all of the different forces that are involved, all of the different ways that the control surfaces interact with the air, and all of that stuff, they are drawn in a graph. There's actually a graph available for the flight characteristics of a plane. Within that is what's known as within the envelope. You stay within the envelope and the plane will perform correctly. You go outside the envelope and it can do unpredictable things. Now the key about that is somebody has to figure out that envelope for any given plane. And that's what test pilots do. These guys are very highly trained. They push a plane beyond its design specs, beyond its actual limitations, and they find the envelope for other people to stick within, to fly this thing safely. And I think that's what we're talking about here, is we need people pushing the envelope so that other people can get in the plane and just fly it. And I'm not sure if that actually came out anywhere near as clear as when it was in my head. But, that's kind of a fun little side story anyway. So
That's a good one. We have one last comment, and then I'm going to close down the comments.
Okay.
not answer any more after this. This is
Hey,
not
it's Tim.
It's from Timothy Parrott.
Yeah,
Who is,
Tim.
recently,
Hey, Tim.
He's also relocated to your area, man.
Oh,
It's
I had
like,
lunch with him like a week ago in the Britannia Arms in San Jose. Him and Runar Bjarnson.
oh, nice, nice.
Yeah, it was good.
Yeah, yeah. I'm jealous, man. I wish I could have lunch with you guys. No one will.
Well, when you're in town, we'll take you there.
All right, all right. It might
Done.
be a little while. Yeah, Tim just says, I concur with Franklin. In Scala specifically, there are so few folks with large system experience using monad transformers and similar tools that we as a community likely can't converge on an Uber solution if one even exists. I think I'm going to agree with that. Where the Scala community is coming from and where it's going, we're moving towards functional programming from imperative. There's not a ton of experience with like really heavy monadic systems, and also there are some limitations in things like monad transformers in Scala, the way they exist. Scala has polymorphism, and in my opinion, if you're going to use heavy stacked monads, you're going to be using the cake pattern in Scala. That's almost a requirement. That's the best, most elegant way you can implement that stuff. And there's just not a ton of experience. Daniel has a good bit of it.
Yeah, I was going to say it's too bad Daniel's in here because he could actually speak to this more than we can.
Yeah, just Scala, the way that the trait system is something that. If we had direct support for the way that Scala wants to do traits, say in the JVM, to like solve some of the binary compatibility issues and some performance issues, doing the cake pattern would actually be the most elegant way of writing lots and lots of software in Scala. I mean, the pattern itself, the way you write code and maintain things, is impractical for reasons that are frustrating to me. I think it's a solvable problem. But also it's very elegant when combined with really heavy monadic usage. But because of practical concerns, it's not viable right now, in my opinion. I'm going to throw it out there. Daniel might disagree with me, but Daniel had a team of people who were rock solid, and I don't think everybody has a team of people that could handle that level of the rough edges.
I'd point out the other problem with it, which is the whole lifecycle initialization thing, which you just have to be very careful around with it. It's very easy to get that wrong. But yeah, but here's the problem. I'm fully engaged now. We could talk about this for the rest of the night, but we probably shouldn't.
Yep. Okay. So that was a great topic. Hope you guys enjoyed that. I just want to throw out there that we do have a email address, thescalawags@gmail.com. We do have I think there's a scalawags at googlegroups.com as well.
I joined the Google group today. I was like, wait a minute, don't we have a group?
We do. We've had like 3 emails on it total.
Which is why I forgot that I was even on there, because I never see the emails come in. But
maybe we should actually announce the podcasts on the group. Maybe.
So the 3 people on the group can join us for the podcast.
And we don't actually like tell people that we have one at the end of every podcast, which we should. And we don't thank like Kevin MacLeod for all his freely available music that we use all the time. But because we don't actually have to, according to his license, which is why he's awesome, and why most podcasts use him. Or
is he Kevin MacLeod of the Clan MacLeod?
I hope so.
That would be awesome.
I think he's a Highlander in disguise.
There can be only one.
There can be only one Kevin MacLeod. And yeah, we have a Google group. If you guys have like what you think is a really hot news item you want to talk about, and even if you want to talk about it with us, send an email to the group. Right? Like that's what we're here to do, is talk. We love talking. Yeah, so thanks to everyone who watched live and submitted questions. That was pretty awesome. Hope you enjoyed it. You guys have anything else you want to say?
No. Yeah, see you in a couple of weeks for the Miles Shapeless talk.
For the ever promised, never arriving shapeless.
Miles
episode
shapeless.
So
will
this
come one
one we
day.
had to coordinate 4 people's schedule, and that's tougher than, or no, 5 people. Sorry, it's
Yeah.
hard enough to do 4. As you notice, Daniel isn't here because coordinating schedules last minute is rough, and planning is also just impossible.
And then throw in a guy who's in the UK time zone as well, and things get really interesting.
Yeah, exactly. Because you never know if he's gonna have. I actually can't finish that thought. It's too late. Cheers, guys.
See you guys.
Yeah.